Hi, this is Amy, and we're going to start talking about statistics. This is our first video, and it's an introduction to statistics, and we're going to start with definitions of basically what statistics is. Statistics is a collection of methods for planning experiments, obtaining data. Then we're going to do some organizing, summarizing, presenting, analyzing, interpreting, drawing conclusions, and all of this is based on the data. We're going to draw those conclusions based on data. Let's pretend that we are trying to make a decision. Our decision is going to be, we are the student association. Should we buy a Coke machine or a Pepsi machine for the student lounge? We're going to go through the process of statistics to help us make a decision. So first thing we do is plan an experiment. I'm going to survey 100 students and ask them, what's your favorite pop, Coke or Pepsi? Obtaining data is conducting the survey. We're not going to be doing that as much in this class, but it really is the most important thing. Let's organize it and summarize it. Organize it might be doing something like this, making a pie chart where this is Coke and this is Pepsi. So I've made myself a little pie chart here. I've summarized it by putting in a summary statement like 62% preferred Coke. Now we can present that either in something like a dashboard, we'll make a little report, tell other people about it. Everything we've done so far is part of our first part of this course, which is called Descriptive Statistics. Descriptive statistics is when we describe things. So I'm saying we're going to describe the data. We're going to look at things. We're going to do things like find averages, draw charts, etc. That's the first part. Now we get to the second part where we are going to analyze, interpret, and draw conclusions. This is called inferential statistics, where we make some inferences. Here, I might write a sentence like 62% of students plus minus 4%, 19 times out of 20, we'll talk about this later, prefer Coke. And now I'm going to make an interpretation. What I can interpret that is Coke is more popular. That is an interpretation. I'm saying I've done my sample. More people in my sample picked Coke over Pepsi, so probably, sort of, in general, Coke is a better choice. Then I'm going to draw my conclusions, and that is, I also like to call this making a business decision, is we're going to actually make a decision here. We're going to buy a Coke machine or sign a contract with Coke, not Pepsi. So we've made a decision there. Along the way, we had our two types of statistics. Descriptive statistics and inferential. In inferential statistics, we generalize. So first we describe, and then we generalize. We say this is true in a sample, so maybe it's true in the population. Next, we're going to talk about populations versus sample. So let's start talking about those two things, population and sample, and decide what they mean. The population is everything. It's the complete collection of everything that we're looking at. So that's the complete collection of data, people, scores, anything that we are looking at. A sample, on the other hand, is a subset or subcollection of the population. So if I was looking at a survey where I wanted to talk about everybody from Canada, I might sample 200 people at the mall. That's my sample, and it represents, hopefully, my population, which are people in Canada. In general, we use Greek letters. We'll talk more about this. And in general, in samples, we use English letters or symbols, accents, in fact. And we're going to talk about some of those, like P with a hat. In general, this is the hard thing. Populations are really hard to know. They're expensive to survey. And if we actually did want to know everything, that's called a census, when we talk to everybody in a population. In general, for the population of Canada, censuses occur every 4 years because they're expensive. Samples are cheaper and easier. And we call them a sample or a survey. Well, we're not talking to everybody, but we're talking to some. When we start to talk about the statistics, or the items that kind of identify it, in a population, we call that a parameter. And in a sample, we call that a statistic. This is where it does get confusing because statistics is the name of the field, but a statistic is something that describes an element. So it's an element of the sample, while a parameter describes an element of the population. I like to remember that population starts with P, and sample and statistic both start with S. That's as good as I've got for remembering them. This might be something like, I want to know the average height of a Canadian. I'm looking for a parameter called mu, and in this world, it's going to be about 180 centimeters. This is a Greek letter called mu, and it stands for the letter M, for mean or average. But the average height in my sample is going to be, let's say, a little bit different. We call that X with a bar, an English letter with a bar on top, and it's going to be actually 175 centimeters. Close, but not exactly the same. I'm going to call that X bar. Next, we're going to talk about types of data. We have actually many types of data, but for now, we're just going to talk about the two main types. That's quantitative and categorical. We can subdivide these further, but we're not going to do that now. You might have heard categorical called qualitative. I don't like that as much because it's not quite as useful, but it is in some books. Quantitative are things like numbers, things that we can take an average of, like a height or a weight or a test score. Those are all numbers, and it makes sense to take them and find a mean average. That's when we find all those numbers, add them together, and divide by the number of things they are, it makes sense. In our categorical, these things are not usually numbers. They could be numbers, but they're not usually. Something like if I ask you, what's your favorite color? That's a category. That's where categorical comes from. What if I asked you, do you prefer Coke or Pepsi? An example of a number that is categorical is your student ID number. It wouldn't make sense for me to take all of your student IDs and add them up together and divide by the number of students. That's meaningless. Instead, what we do is we count the number of things in a category. And we call this a proportion. And this might include something like 62% of people prefer Coke, where the mean average might be something like the average height is 180 centimeters. Averaging things doesn't make sense in a categorical world. If I ask everybody their favorite color, I can't find the average favorite color, but I can say that 11% of people like purple, or most people, the biggest category or mode is blue. So let's say blue was given the most often. That's not an average per se, but it's still a useful piece of information. Let's do some examples. Just make this a little bit bigger. Identify the type of data and whether we are estimating a mean or a proportion. First, you want to estimate what percentage of BCIT students have a cell phone. You randomly select 200 students and 192 respond yes and 8 say no. What type of data is this? It's categorical data because it's yes, no. And we're looking for a proportion. Here, the proportion P hat is going to be 192 over 200, or 96% of students have a phone. I'm not sure about those 4% of the rest of them, but 96% have a phone. 2, you want to estimate the average or mean amount that students spend on their cell phone per month. You ask those 192 students from question 1 how much they spend per month on their cell phone and obtain an average of $50 per month. This is going to be quantitative because it's a number and we have an average here. We're looking for a mean average, and here it's going to be X bar because it's a sample is $50. So our sample average is 50.